Swayam Prabha. Digital India. Educated India.
So, this lecture I will start a new topic on pile foundation. So, the pile foundation are already been discussed in the foundation engineering course, but this advanced foundation engineering course I will mainly discuss in detail those topics, those are not covered in foundation engineering course. Though due to maintain the continuity, I will also discuss few of the portions, those are already been discussed in foundation engineering course, but not in detail, in brief. So, in this course I will mainly discuss that how we can generate a load settlement behavior or load settlement curve for pile analytically, because we know that we can get the load settlement behavior of the pile by using pile load test, but this course mainly I will discuss that how we can generate a load settlement curve for pile by analytical approach or theoretically. And then I will also discuss different cases for negative skin friction, and other things are already been discussed in the foundation engineering course. So, I will briefly discuss those things and to maintain the continuity. So, before I go to the main part of this topic. So, briefly I can discuss that what are the uses of pile. So, the pile can carry compressive load, pile can carry uplift load, pile can carry lateral load also, even incline load also. Depending upon the type of structure, we can provide a pile which can carry different types of load, not only compressive load, it can act under uplift load, under lateral load also. So, when you are talking about the pile under compressive load, so this pile can get the resistance by two mechanisms. One is the screen friction and another is the tip resistance in the bearing. So, based on that we can classify pile into two groups, one is the end bearing pile, another is the friction pile. Now, if all or the majority amount of the load are transferred to the pile tip, then it is called the bearing pile. That means, most of the or majority of the load is taken by the soil which is below the pile tip, or that means, most of the resistance pile is getting from the tip or the bearing. So, what is the example? That means, suppose if we have a very soft soil and then there is a hard strata. So, that means, this load is transferred to the hard strata through this pile. So, majority of the load will be taken by this hard strata and the pile will get the resistance from the tip. And but if all or majority of the load is transferred to the soil along the length of the pile, then it is called the friction pile. So, when you are talking about the load transfer mechanism, so that means, as I mentioned that there is a friction resistance and the tip resistance. So, first the friction resistance is mobilized, then the tip resistance is mobilized. That means, when you apply a load, first pile will get the resistance from the friction. In that time, the resistance due to tip is also there, but that amount is very less compared to the resistance that pile is getting from the friction. Once the friction resistance is fully mobilized, then the tip resistance, pile will get the tip resistance. Okay, so, that means, the second part, once the friction resistance is fully mobilized, then the resistance that you will get is due to the tip resistance only. So, suppose if the pile is that friction resistance that pile is getting is sufficient to take the bearing capacity or the load carrying capacity of the pile, then that means most of the resistance is due to the friction, then that type of pile is called the friction pile. Then pile can get the uplift load also. The application areas that below the some structures such as transmission tower, offshore platform, where the piles is subjected to uplift also. In transmission tower, because when there is a wind, so it will try to rotate the structure. So, the one portion of the pile will be under compression, another portion of the pile will be under tension. So, that transmission tower, then offshore platform where the pile can be subjected to uplift also. Then pile can be subjected to horizontal or inclined load. For example, the foundation below the retaining wall, bridges, abutment and wave, when there is a waves from the water, then that type of situation pile can carry the horizontal as well as the inclined load. Now, lateral loaded piles means if horizontal load acts perpendicular to the axis of the pile, then that type of load is called the lateral load, and that type of pile is called the lateral loaded pile. And then batter pile also, if pile is subjected to inclined load, then we can provide an inclined pile or the batter pile, so which is driven with certain angle and carry horizontal load as well as the inclined load, because inclined load has two components, one is the horizontal components, another is the vertical components. And if the horizontal load is perfectly perpendicular to the axis of the pile, then it is called the lateral loaded pile. Now, in terms of material, the pile can be timber pile, concrete pile, steel pile. Then timber pile is suitable for lightweight structures and suitable for soft cohesive soil. Concrete pile can be used for all condition. Most frequently used pile, strong and durable. Then steel pile can be used to carry heavy load. Now, there are different shape of the piles, that means cylindrical pile, tapered pile, then under rim pile, that means under rim piles we provide bulbs. So, that can be suitable for expensive soil. Then cylindrical pile is suitable for cohesive soil underlaid by a granular soil. Loose to medium drain granular soil, tapered pile is suitable, because here we can distribute the pile material or we can transfer the load along the pile very effectively if I provide the tapered pile. Then mode of load transfer, as I discussed, there is end bearing pile and the friction pile, and there can be a combination of these two. That means, some portion of the resistance pile is getting from the tip and some portion it is getting from the friction. So, for end bearing pile, it transmits the load through weak soil to a hard stratum, and the ultimate load carrying capacity of the pile is equal to the pile, the resistance that pile is getting from the bottom. And then the friction pile transfer the load to the screen friction between the embedded soil and the pile, and ultimate load carrying capacity of the pile is equal to the load transferred by the skin friction. And if it is a combined pile, then the ultimate load carrying capacity of the pile is the summation of the load transferred by the skin friction plus and the load pile which is getting resistance from the tip. Now, pile can be driven pile and boat pile and jetted pile. So, driven piles are suitable for loose granular soil, where when we apply drive the pile into the soil, then there is a possibility that the compaction of the soil. So, that we can increase the shear resistance of the soil. Then boat pile is best suited for clay soil, and jetted pile is suitable if the granular soil is in very compacted state. Then pile can be precast pile, pile can be cast in situ pile. So, pile can be precast or pre-stressed pile which can be used for the marine structure, and pre-stressed pile have larger vertical load and bending moment capacity and are used in such installation where the bending moment and the vertical load are in very large amount. And then the cast in situ pile, soil of poor drainage quality and suitable for place where vibration are avoided to save the surrounding structures. That means, during the installation of precast pile, there is a possibility of vibration, and if the surrounding structure cannot take that vibration, then we can go for the cast in situ pile, or we can go for the cast in situ pile for the site where the drainage quality is very poor. So, then we have the displacement pile and the non-displacement pile. So, all driven piles or the piles which are drive into the soil are displacement pile, because the soil is displaced laterally during the installation of the pile. And non-displacement pile, bore piles are generally non-displacement pile, where the possibility of displacement of the soil laterally is very less. Then we have different pile load capacity methods. So, we can determine the capacity under compression by static pile equations, then pile load test, then pile driven equations, then correlations which is available based on the penetration test data. Penetration test data means the SPT or the SCPT. Then static pile load equations. So, as I mentioned, the pile capacity is basically due to the skin friction and the tip resistance. So, that means the ultimate load carrying capacity of the pile is a summation of tip resistance or the point load resistance and plus the friction resistance or ultimate friction skin friction. So, that means for point bearing pile, the friction resistance is very less compared to the tip resistance, and for the friction pile, friction resistance is very high amount compared to the tip resistance. So, we have these equations. So, that means here ultimate load carrying capacity of the pile is summation of the tip resistance plus the friction resistance. Now, Q small q Pu is the friction tip resistance. Now, if I multiply it with the base area, then I will get the total load that the pile is getting due to the tip resistance plus the friction resistance into the surrounding area, that means the perimeter and the length of the pile, that will give us the total frictional force. Then how to calculate the point bearing resistance or the tip resistance? Now, as we know, this equation is the basic equation for bearing capacity calculation. So, C N C Q dash N Q plus half gamma B N gamma. So, and if I use the another general equation where some factors are also multiplied, but here this is the general equation. So, in case of pile, so this is the third term is very less compared to the second term, because the length of the pile or the depth of the foundation is very large. So, third term is very less compared to the second term. So, generally in pile load carrying capacity, this third term is been neglected. So, we will get the CNC plus Q dash NQ. So, NC NQ are the bearing capacity factor, and then sigma dash or the Q dash is the effective overburden pressure at the tip of the pile, okay? And C is the unit cohesion and B is the width or diameter of the pile. Now, for the granular soil, the tip resistance is simple sigma dash into NQ, even the first term is been neglected because C is 0. And for clayey soil, the tip resistance is equal to CNC. Okay. Second term is also neglected. So, for the say clayey soil, tip resistance is simple CNC, and for the granular soil, tip resistance is sigma dash into NQ. And remember that CUB is the undrained cohesion at the base of the pile. So, now how we can determine the tip resistance for the pile? There are different methods are available. So, I will discuss two of them. So, first method is the Tomlinson's method, where the expression is same, the sigma dash into NQ, and then the NQ value we will get from this chart. Suppose if this chart, this is x axis is the phi value and this is the NQ is the y axis, different L by D, L is the length of the pile, D is the diameter of the pile, we can get the bearing capacity factor. Now, if we put this factor here, we will get the tip resistance, but remember that in this method it is suggested the tip resistance is limited to 11,000 kilonewton per millimeter. That means, we cannot use the tip resistance more than 11,000 kilonewton per meter square for this method. Okay, so now, if the phi value is greater than 40 degree, then when we apply the when we driving the pile, there is a possibility of dilatancy. So, which may reduce the friction angle or the shearing resistance of the sand. So, we have to reduce the friction angle if the friction angle is greater than 40 degree, and that equation is given here, phi plus 40 degree divided by 2, but it is applicable if friction angle is greater than 40 degree. So, remember these equations are all given for the driven pile. We have to, if I want to use this equation for the cast in situ pile or the boat pile or boat pile, then you have to modify them, but these are driven pile, not for boat pile. Now, similarly, there is another expression is given by the Mayer-Hupp. The expression is same, but this tip resistance we can get this NQ value by using this chart, where again the friction angle and corresponding NQ. So, these y axis, the left side is for the bearing capacity factor and right side is for the critical length by D. Now, what is critical length? So, I will discuss this critical length part later on, but now, so here from this chart I will get the NQ, and this NQ I will put here, and then but like the previous method also, here also we have to give some limiting value. So, that limiting value is 50 NQ tan phi kilonewton per meter square for dense sand and 25 NQ tan phi in kilonewton per meter square for loose sand. Okay. Now, we will go for the screen friction, because previously we discussed for the tip resistance, now screen friction. So, screen friction, so this is the screen friction. So, we will calculate the lateral resistance or lateral force or stress which is acting on the pile, and that we can determine that we can calculate the vertical stress at any point, and then we multiply the earth pressure coefficient, and then if I go for the tan delta, we will get the total resistance or friction resistance that is acting along the pile. So, that is done here. The sigma v sigma dash is the effective vertical stress at any point. If I multiply with the k, k is the lateral earth pressure coefficient. So, this is lateral earth pressure coefficient into tan delta. Delta is the angle between the pile and the soil. So, now here remember that we have to take the average effective overburden pressure. Okay. So, at suppose if we have a length of L, so along that L, what is the average effective overburden pressure that we have to use to calculate the screen friction. Then once we get the screen friction, you have to multiply with the perimeter into the length, then we will get the area, and then we will get the total frictional resistance. So, now there is a term K and the delta. So, this Brom's recommended some delta and K value, and which is given in this table. For loose sand steel pile, K value is 0.5, for dense sand 1, concrete 1 to 2, timber 1.5 to 4. Similarly, delta for concrete is 0.755. So, now when it is called loose sand and dense sand, that is also given in this chart. Now, if the phi value is less than 30 degree, then it is called the loose sand, and if it is 30 to 36 degree, then it is called medium dense sand, and it is 36 to 41 degree, around 40 to 41 degree, then it is called dense sand, and from 41 and above it is called a very dense sand. So, here for dense sand and loose sand we will get the different K value. So, now once we are talking about that, we have to calculate the effective stress or average effective stress or effective overburden pressure at a point to calculate the screen friction. Now, here suppose if we have a pile and it is expected that as depth increases, the effective stress or effective overburden pressure also increases. This is gamma into H. Effective overburden pressure is also increases, but it is observed that after a certain depth, in case of pile, this effective overburden pressure will not increase, it will remain constant. So, that depth is called the critical depth. So, you can see here up to the critical depth, this is increasing linearly, but after that it is uniform. Okay? So, this critical depth is vary from 15 d to 20 d. So, for loose to medium sand it is 15 d and 20 d is for dense sand. So, d is the diameter of the pile. Now, that means here we are providing some limiting value even in case of friction resistance calculator, because we have discussed, I have discussed some limiting value for tip resistance calculation for both the methods. Similarly, here also we can provide some limiting value for friction resistance calculation also. Now, this critical depth is obviously the function of the soil condition, whether it is a dense soil or loose soil. And then, but some cases researchers are observed that this type of critical depth does not exist in the field. So, they have suggested that you take the full resistance, that means the from top to bottom the effective overburden pressure increases linearly. But I would recommend that you use the critical depth concept when you calculate the friction resistance. Okay, so, now once you calculate the friction resistance and the tip resistance, then you add them, then that will give you the ultimate bearing capacity of the pile, then divide it with the factor of safety, that will give you the allowable load carrying capacity of the pile. Now, those equations are given for the driven pile. Now, for the boat pile, the tip resistance is half to 1/3 of the tip resistance value that you will get from the for the driven pile. And in case of boat pile in sand, the lateral earth pressure coefficient can be calculated as 1 k equal to 1 minus sin pi. Okay, so, that means the value of k varies from 0.3 to 0.75, average value 0.5 we can take, and delta value is generally taken as phi for the dry soil, and if it is the slurry is used during the excavation, then we have to reduce the value. So, that means for the dry soil we can take delta equal to phi and k value average is 0.5. This is for the boat pile, and for the tip resistance, boat pile tip resistance varies from half to 1/3 to the tip resistance of driven pile. So, now quickly I will solve one particular example problem. So, to calculate the friction resistance and the tip resistance for the sand, and later on I will also solve one problem related to the clay. So, this is the pile so which is a in homogeneous layer, but the water table position is at 1.5 meter from the top, and the pile length is total pile length is 20 meter. Okay, so, diameter of the pile is 0.3 meter, friction resistance is 40 degrees, then L by D is 20 by 0.3, which is 66.7. So, corresponding NQ as per Tomlinson method. So, you can see as per Tomlinson method. So, phi is 40 degree, this is around here. So, this value will be around 130. So, NQ value will be around 130 if I use the Tomlinson method. So, NQ is 130. So, now here it is a 40 degree means it is a dense oil. So, as I mentioned up to 40 to 41 degree it is a dense oil. So, for the dense oil L critical by D is taken as 20. So, L critical will be 20 into 0.3. So, that will be equal to 6 meter. So, up to 6 meter it is a critical depth of the pile. Okay. So, after that the effective overburden pressure will not increase or change. So, if I draw the distribution, so this is for the up to water, then the up to critical. So, after that it will become uniform. So, this is the effective overburden pressure distribution. So, here this value is okay. So, gamma bulk is given 19 kilonewton per meter square a meter cube, and gamma sat is given is also given 19 kilonewton per meter cube. So, both gamma bulk and gamma sat are given 19 kilonewton per meter cube. So, in this portion, that means at 1.5 meter below the ground surface, the stress is 19 into 1.5. So, that will be equal to 28.5 kilonewton per meter square. At critical depth point, the value will be that 28.5. Now, it is below the water table plus 19 minus 10 into, that is 6 minus 1.5. So, this will be 4.5. So, this is 69 kilonewton per meter square. Okay. So, unit weight of water is taken as 10 kilonewton per meter cube. So, this 69 will continue up to the tip of the pile. Okay. So, now tip resistance of the pile QPU will be sigma dash into NQ. Now, sigma dash is here 69. So, that is 69 into 130. So, that is equal to 8970 kilonewton per meter square. Okay. So, which is within the limiting value. So, QPU, the total tip resistance, so that is area which is 0.pi d square by 4 into 8970. So, which is 634 kilonewton. Okay. Now, we have to calculate the friction resistance. Now, here we are taking delta is equal to 0.755. So, 0.75 phi is equal to 40 degree. So, this is 30 degree, and for dense soil it is concrete pile say. So, dense soil K value is 2. Okay. So, for the loose soil K value is 1, dense soil is K value is 2 if the soil is in between that. That means, here it is 40 degree. For 40 degree phi K value is 2, 40 degree and above, and for 30 degree and less K value is 1 for concrete pile. So, if the soil is in between 30 to 40 degree, then you can take K value in between 1 to 2 for concrete pile accordingly. Okay. So, now this is the K value. So, in the next class I will discuss that how we can determine the friction resistance, because I have discussed the tip resistance and I have also discussed the pressure distribution along the pile considering critical depth concept, and in the next class I will discuss how we can calculate the friction resistance, and then we have to calculate the total load carrying capacity of the pile. Thank you.